look at is called RPC info, and it basically does what the name implies. People who've been doing pen tests for a long time have kind of become accustomed, I think we have, to basically you see the port 111 RPC bind open on the system, and then in another window you do RPC info -p target name to get the list of RPC ports, services, and port numbers available on that machine. Well, the feeling was, wouldn't it be nice, even though that's not too much of a pain, when you have thousands or tens of thousands of machines, it is a pain. Wouldn't it be nice if Nmap, if it detects the port open, could automatically do that for you and place the results right next to that port 111 so you have everything together and convenient. And so let's look at how that script is implemented. And the great thing of these helper libraries is that this script, as you can see, is only 46 lines long, less than 50 lines to give you all that information, and that's because it's making use of our RPC helper script or library. So we have a description, basically says what the script is, and that's for generating that NSE doc. Similarly, the output that the script does, as you can see, it basically looks like what you would get from the RPC info command. It has a few fields you have to give, like the author, license, categories. This one's in discovery because it discovers more information, and it's also in safe because it does a pretty standard function that the service was made to do. It requires a couple helper libraries, short port, and more importantly, RPC. And then we get to what's called the port rule. And basically it would be terribly inefficient if Nmap ran this RPC info against every single port that it finds open. It's going to do no good against web servers and most other services. It only works in very specific cases. And so with the port rule, you tell Nmap that the rule is if port 111 is open, or if it's any port number and it's the RPC bind service detected by version detection, and if it's the TCP or UDP protocol, this script can handle RPC bind on both. In that case, it tells Nmap, okay, this is a port that this script is interested in, and so we run what's called the action function, which is right here. And the action function takes information on the host it's running against and the port it's running against. And here's really the key line here, where we say rpc.helper.rpcinfo. This is basically our helper function for grabbing the RPC info. And we say if that failed, return an error message. And then this part is just a loop that says for each of the RPC services we found, put those into a pretty table to show the user. We do a table.sort on the results so that they're sorted. And then we do standard NSE.format output to, again, that just makes the output prettier and more consistent with how Nmap scripts normally do it. And we pass it this string of RPC results that we've generated. So it's actually, as you can see, quite a simple script, but does a pretty useful function for your scanning. So that's one script. And now I want to look at one which is a little bit more complex, but not dramatically so. Let's take a look at that script that had us so much fun, the SMB enum users. Oops. So this one we can see is 262 lines. So it's about 5 times as long as the RPC info. So let's take a look at what it has. So we start with the description again. And Ron is a very verbose person. He actually does great comprehensive and complete documentation, which is really wonderful when you're trying to figure out how a script is working. And so we go on through the description and the usage information and the output information. I was thinking of changing the output to the Microsoft stuff for the default page, but the argument documentation for the arguments that it takes. And so here it's really starting the code, and we're to line 141 of 262. So more than half of this script is documentation. So now let's get to the meat of it. Now the last script was what we call a port rule script. And so it runs against a certain port that was found open. If there were three RPC bind ports open for some reason on the machine, it would have gathered the information for all of them. This SMB script is called a host script because it runs once per machine. And so it has what's called a host rule, which tells Nmap which hosts to run against. And in this case, it's pretty simple. It uses an SMB helper function that says get any SMB or MSRPC port from the target machine if there is one. And we check if it's not equal to nil. So if we actually got a port from the machine, if it's got no SMB ports, it would have returned nil, and Nmap would have skipped the script for that host. But if it does have an SMB port, Nmap runs the action function again. Here we have a lot of variables. And you can kind of see that even if you don't know Lua specifically, this is the same sort of stuff you do in any scripting language. And so you can recognize the variable declarations, the operators. Here we first try and gather the usernames through SAMR, which is a little bit, it's the most effective of the means of gathering the usernames from an MSRPC server. And then we also try doing it through LSA, which is not quite as effective, but sometimes you can't get them through SAMR. We take these results and then we format them again. We're kind of limited on time, so I'm not showing like each line, but we format them, we sort them. Ron did a smart thing in that he breaks them up by domain. So if a domain controller, there could be several domains and you can get them listed by each. We check, this is all more formatting, you know, all those different extra information we got, like the people's full names and nicknames and password details. It's doing all that. If you're in verbose mode, it's still creating the response. And then finally we get this final line again, which says, Nmap, here's the string we formatted with all the results. Please present this to the user for that host. So now we've seen two examples of NSE scripts in basically how they're coded. And we could go on and on with that, but what actually seems like it would be more fun is to do a demonstration. David is actually one of the best script developers on the planet, and he's going to show us how you can actually write a script on the fly, from scratch, with hundreds of people staring at you for any mistakes you might make. And he's going to do it right now.
Thank you very much. All right, so let's prove how easy it is to write an NSE script. This is something that I think any programmer can do. Let's demonstrate this kind of on a toy example. Before I left home, I set up a webcam aiming out at the beautiful city of Denver, and I want to try and see that webcam picture. The problem is, you know, it's on my standard home internet connection and it's on a dynamic IP address, and I don't know exactly what the IP address is. So let's write a script to find it. Before I left, I found out a couple of attributes of this webcam that'll help us fingerprint it. It serves a file called cam.jpg. The server is HTTPD, and I found that that's enough to reliably find this webcam. So we're just going to open up a file. The customary file extension is .nse for scripts. Script has to have a description. Categories for this script. It's a pretty safe script because we're not doing anything weird with HTTP, and I would also put it in the discovery category. Port rule, this is what decides if the script is going to run. Here we just want it to run for HTTP ports. So this is going to be a simple rule. Return port.number equals 80. See, Lua is easy. Now the action function, this is where things really happen. Now since we're going to be using the HTTP functions, I have to go back and we're going to require the HTTP library. A local variable here for the HTTP response. Response equals http.get host port. We want to retrieve the file cam.jpg. And now we want to test if this actually works. So we're going to say if response.status and response dot status is not equal to 404, right? Because that's no good for us. This is how you say not equal to in Lua. And response.header, we can query the header values, so we're going to look for the server value here. First, we're going to check that it exists, and then we're going to check its value. String.match is a standard Lua function. And we're going to match it against the pattern THTPD. Then, it's real easy to return results from an NSE script. You just return a string. Oops. And so this is it. In case we don't find it, we just return nothing, and that's going to make the script remain silent. So let's give this a try. I'm going to run an Nmap, I'm going to run this script, and I'm going to add a couple of options that make this scan faster. So pay attention here. You might learn some tricks in case you have trouble with the speed of your Nmap scans. We're going to turn off reverse name resolution, turn off ping scanning. We only want to scan port 80. I only want to see hosts that have an open port. We want to run the script HTTP webcam. The ISP's address space is what I want to search here. Let's log the results to a file just in case it scrolls off the screen. And finally, this is a good tip. Always add the debugging flag when you're testing your NSE scripts, because that way when you have a syntax error or something, you'll get a backtrace. As if. I mean, we're just testing this out for the very first time in front of a room full of people. What could possibly go wrong? Give this a try. Okay, so Nmap is fast. Let's open up the results file. Webcam found. Excellent. So we found it at 66.7.171.5. And that's all there is to it. Oh, you want to actually see the webcam? All right. Yeah, sorry. I did check to make sure this would work, but... Huh. Okay, so we have a little problem here, but let's not be daunted. To an Nmap developer, there's always a solution. The solution usually involves doing more scanning. So let's do this. Here's the game plan. Are you with me? So let's start again with the description. Guesses HTTP passwords. All right, so we can't really justifiably put this in safe anymore. I want to require, again, we're going to need the HTTP library. We're also going to bring in our username password database library, because that's going to do the hard work of password guessing for us. Port rule is going to be exactly the same. Action is going to be a little bit different. We need some local variables here. We need a usernames iterator, a passwords iterator. We're going to need an additional status variable.